Hello, I'm Sang-Hyun, and I will present our paper, Style Injection in Diffusion. In this paper, we focus on solving the style transfer, which is the task is transferring the style of given image to the content image. Thanks to recent advances in diffusion models, there are several works to deal with style transfer using diffusion model. However, they require inference stage optimization such as texture inversion of style image, or fails to leverage the generative capability of large-scale pretend diffusion model. These approaches has their own pros and cons in terms of generative capability and speed. In this paper, we aim to leverage large-scale diffusion model of style transfer without any optimization for utilizing its prominent generative capability and faster speed. Recent diffusion model-based image-to-image translation method reveals the attribute of attention layers. For example, plug and play show the attention map of self-attention determines the spatial layout of generated image. And also, prompt to prompt shows keeping the cross-attention map while changing the value of text condition only adjusts the content of generated image while keeping its structure. In this paper, we utilize these characteristics of attention layer, especially with self-attention map, for keeping the layout of content while transferring its texture. Specifically, we observed that the substitution of key and value effectively enables us to synthesize the realistic images with modified texture and styles. In addition, we show that the self-attention of large-scale diffusion model has desirable characteristics such as that query in self-attention represent the semantic patch similarity, and the similarity measurement between query and key accurately reflect the style. Based on this motivation, we propose the style ID, which leverage large-scale diffusion model without any optimization. Style ID consists of style injection for manipulating the content and style of generated image, and initial latent adaptive instance normalization for transferring the color tone of style image. Style injection composes of the procedure called style injection and query preservation. We first obtain the query and key and value features of content and style images during the DDI inversion. Then we inject the obtained query of content and key value of style in the reverse process. Style injection substitutes key and value of self-attention with those of style counterparts to transferring textures. And query preservation added the content query feature during reverse process for preserving the spatial layout of given content image. Additionally, we scale the attention map to calibrate the magnitude of attention. This is because, in our case, attention is calculated between query and key of two independent images different from each original usage. Despite this style injection, we observe that the color tone of stylized image resembles its content. To transfer the color tone, we apply ADA-in on the initial latent to change the channel statics of the latent. We observe it successfully transferred the color tone of style while keeping the spatial relationship of content. As a result, we validate the proposed method achieves state-of-the-art performance in style transfer metrics such as ArtFID, NFID, and LPIPS. For the evaluation study, we observed the proposed component gradually enhance the ArtFID metric. Style injection enables us to transfer a style while preserving the original content. Attention scaling reduces both FID and LPIPS by calibrating the attention map and keep the sharpness in the generated image. Finally, initial latent ADA-in enables us to transfer the color tone. And also, we analyzed the effect of query preservation ratio and temperature scaling parameter. We observed that query preservation ratio adjusts the effect of self-transfer, and temperature scaling both reduces FID and LPIPS. Sum up, for our contributions, we extend the application of large-scale diffusion models to style transfer with our proposed method called style injection in diffusion, which comprises three key components. First, attention-based style injection inject the style and content features in reverse diffusion process for transferring the style and content of given images. Second, attention temperature scaling calibrates the statistics of attention map similar to values in its original usage. Initial latent adaptive instance norm transfers the color tone of style image while preserving the structure of the content image. We demonstrate the superiority of proposed method over both conventional and diffusion-based style transfer methods through comprehensive validation.